Welcome everybody. Tonight we're going to be working on our lab assignment and the regular assignment for Module 5. But before we do that, when we ended our session last week, we got to the very end of the PowerPoint. And I don't know if you recall this, and we started talking about this concept of dictionaries, right? This thing where we have a key value pair. Remember that whole thing? And then at the very end of the slideshow, they had this try it out. And, frankly, I was kind of tired, didn't really want to code through it at that point in time. But I thought we could code through this tonight because this is a fun little exercise. Um, and it's a good one for problem solving, in my opinion, because you can kind of learn how this works and then think about some techniques for analyzing stuff along the way, and I'm hoping you find this helpful. I am going to pull Visual Studio over onto my main screen here, if it will let me. Okay, the splash screen is the only thing I can move right now. I am going to go, well, actually, you know what? I'm going to add this, and I'm thinking about this really carefully, to my try it out file that I already have. And I'm trying to be strategic about this because the solution is already embedded in there. So I want to basically strip it out. And you know what? I'm going to drop it into, I'm going to change the way I'm doing this. So I apologize. This is a horrible way to start a video, but I'm going to start a new project, I think, and I'll just put that one in there, right? Because I already have it added because I coded it after class, basically. All right, so we are going to build a new console app. I'm going to call it Mod 5 Try It Out. And this is going to be a dictionary example. That's what I'm calling mine. You can call yours whatever you want if you're following along even. I'm also going to put this where I've normally been putting my WCTC stuff, which is here. We're selecting that folder. And then we're just taking the defaults from there on in. All right. So Visual Studio, of course, opens up on screen number 2. Let's clear out all this stuff from here. And then let's look at the instructions. It says, create a letter counter. Ask the user for a word or phrase. Use a dictionary to count how many times each letter occurs in the input. Hint, the key is the data type character and the value is the data type int. So we're given at least something to start with. So they want us using a dictionary and they want the keys to be characters and the values to be int. So in other words, the key will be the letter, right? So if we find the letter E, for example, that will be my key. Then every time the letter E happens in the string that's typed, I'll count it, and that will be the value. Right. So the letter becomes associated with the value. And then we're going to do an output kind of like what we see here, which is to output stuff. All right. So let's start with a couple of little tidbits here. We are going to be using some import statements, or what I call using statements in C#, right? We talked about this a little bit last week. And what I'm going to do is I'm just going to drop those in right away, right at the top of the file, right? And if I don't put these in, here's what will happen. I'll put in like the dictionary thing and it'll underline red, and then I'll hover over it and it'll say at missing a using reference, do you want to add system.collections.generic? And then we say yes, and it adds it automatically. I'm doing it preemptively because I know it needs to be there, right? Maybe at some point, maybe I'll remove it so you can see like the errors that it throws, so you know how to like fix it. That's a thing, because sometimes what we do as coders is we dig right into the code and we don't worry about those imports at all, and then we think about them in the aftermath. And actually, that's not a bad way to work, honestly. All right, let's move on to the next thing here. Well, we're supposed to prompt the user for input. Okay, so here's what I did: is I just put together a prompt and I said, enter string, right? I know the slide says some different stuff, but we're going to capture it. We're going to store it in a thing called input, right? We also know, because we were told basically that we're going to put this stuff into a dictionary, right? And I'm going to create one by using the keyword dictionary. Notice the angle brackets on this. And then because dictionaries use key value pairs, and we already were given the tip that the character should be the key and the counter or the integer will be the value, right? We're going to call it character counts. You can call it whatever you want, really. And then we're going to instantiate or create a new version of the object, right? And we're just going to say new dictionary character int. And remember, the weird thing about dictionaries is you have to put the parentheses at the end, which is really odd, but that's just how it works. Right. And really what it's telling you is there's a thing that we call a constructor function. We haven't learned about objects yet, but that's really what that's invoking, is a function that builds the object, right? So that's, now we have a dictionary that's ready to store information, right? With key value pairs. Next thing that we want to do is we're going to have this string the user typed in, and now we want to basically traverse that string structure one character at a time. And then as we look at it, we'll check to see, all right, is it one that we already have? And then if it is, then we'll add to the count for it in the value part of the key value pair. If not, we'll add it and then count it. Okay, so that's kind of a thing. All right, so let's kind of look at some basic code for this. I am going to use a for each loop to do this. And so here's my little thing there. I'm going to iterate through each character in the input string. And watch how I do this. I'm going to say for each. Remember, the for each thing it operates automatically. I think this is really interesting too, because it automatically threw in the keyword var, not what I would normally use, but it would actually work. That's the other aspect of this. But I want to enforce the fact that the thing that we're traversing is a character. So we're going to look at that string one character at a time, like we do an array, right? Like one position at a time. And so I'm looking at each character in the input string that the user entered. All right, that's kind of the plan. All right. One thing that I noticed in the example is, where is that? Right here, that they were counting spaces. I don't know that I necessarily need to count that. I'm more concerned about the letters. And so I'm going to write a little snippet of code to show you like how I'm going to ignore the spaces. And I'm going to throw in this weird thing, and we haven't talked about this at all, but this is a function that's built in to processing strings, which is called is white space. So in other words, if it's a space, continue. You guys remember what the continue command does in the loop? It pops this out of the loop and restarts it and doesn't process any more of the code. So if I hit a space, so is white space, so it returns true or false. And if it hits one, it just skips this iteration of the loop and goes to the next letter, right? So if you want to count the spaces, you could omit this, basically. The other thing that you could do is you could put in a thing here that takes every character in the input string and turns it into either uppercase or lowercase. So like, for example, if you're counting capital letter A or lowercase a, you're counting the same thing. Okay, I'm not going to do that, right? But you could, right? How would I do that? I would just take input, or excuse me, the character that we're sending in, which is C, and I would say two lower or two upper, right? It's really as simple as that. Not very hard to do. let's get into the logic part of this. So, um, and wow, that's exactly what I was going to type. So, it always blows me away with Visual Studio when it gets exactly the code I want to type. It just blows my mind, right? Welcome to the future, folks. All right, so if the character counts, in other words, we're going to basically start um, by keeping track, right, of the character count in uh, the string here. And um, this is a variable that we're kind of creating, right, along the way. And we're looking at this other function. So these are functions that you might not normally think about using, and we really didn't talk about in the lecture, but I'm demonstrating some new ones to you just so you have a bigger arsenal. But we're going to look at basically the dictionary, right, which is called character counts, and we're looking at the current character we're processing to see if we already have a key with that letter. That's what's going on here. So, in other words, if the first letter is T, right, it looks inside the dictionary and says, hey, do you have a key with the letter T? All right. If you do, well, here's what we're going to do. We're just going to take the character counts. Oh my God. Once again, perfect. Thank you, Visual Studio. Um, for that particular key, and we're going to plus plus. Yeah, we're going to increment. So we're going to add one to the count. So whatever the key started out with, we're adding one to it. Remember, when we're dealing with collections and we initiate a dictionary or any of those structures, the default value that goes into the position is 0. By clicking this, we're making it 1. So it's not like it's not initialized, it's initialized automatically. Right, so that might be a question you have in the back of your head. Otherwise, this is a new letter we're finding, right? And if that's the case, and yeah, once again, real close, Visual Studio, off by 1, we're going to set it to 1, right? So if it's a new letter in the list, we're going to take that key and store the value of 1 with the key. So the letter will be stored in character, and the number will be stored in the int, or the value, right? That's the logic for counting it and traversing it. There is nothing else. This is remarkably simple, right? And this is cool just because it's that simple, I think. All right, now we need to output the results so that we know that it worked. So we could just do a simple kind of output like this, right? Print the results, right? And then think about what's going to happen next. We have a dictionary that basically is storing all the information, a letter and a number, a letter and a number. And we know that a dictionary is kind of like an array, except it's got 2 values for each thing, right? The key and the value. And it's a structure that we can traverse. It's a repeating structure. So a for loop is a good one. And I'm going to just kind of keep reinforcing the for each thing here, since we haven't done really a lot of that. And I'm kind of looking at what it's creating here. Yeah, that's not exactly how I want to do it. I think I'm going to do the var approach this time. So I'm going to call it pair, meaning key value pair, in character counts. That's what I'm traversing. So, and the reason we use var, remember, is that way I don't have to worry about saying dictionary with the angle brackets and listing the car and the integer. You guys remember that from the slides, where there's a long way to do it and a short way to do it. And then when you're looping through it, you just use var, call it a key value pair or a pair or something like that, and just roll with it. Right. Then all we have to do is output it, right? And so the trick to this is just having the right syntax. We're doing a console write line, we're string interpolating, and then pair is the variable we created locally to read in the key value pair. But there is a key and there is a value, and we're just pulling them out separately. And notice we're putting in a colon in between them. All right, so let's try it. Here's the run. It's up on screen. And we need like, a little bit of a sentence here. So we'll say the rain in Spain falls mainly on the plain. You guys remember that phrase from pop culture? Okay, maybe not. I think I'm dating myself a little bit. Older people go, yeah, I totally know that. Okay. All right, but check it out. Notice it went through each letter in order, and every time it found a unique letter, it would throw it in the dictionary and then count it. And then every time the letter would happen again, it would just add to the count. So there's some letters like the N, right? Happens 6 times, I happens 5, A happens 5 times, but it did work. Interestingly, it did count the period, right? If I want to count the spaces, right? The easy fix for that is to basically comment this out. If you're wondering, so we can just run it again. I suppose I should probably terminate this properly and run it again. And let's type in, hey, whatever the heck, snow sucks, right? And notice how it got hey, like those are all individual letters, got to the spaces, and then it counted all the spaces. Pretty slick, right? Simple and pretty darn slick. All right, so that was the try it out that we didn't do the other night. I am going to go ahead and close the solution, and now we'll switch our attention over to the first lab exercise. Let's read through the exercise first, though, before we start coding it. All right, so let's read the instructions. It says create a program that tracks UFO sightings for a work week, Monday through Friday. The program should ask the user for the number of UFO sightings for each of the 5 days. The program should output the days sorted from least to greatest and use parallel arrays to store day names and sighting counts. Loop over the arrays to store the user input and print output. All right, so we're going to prompt them a whole bunch of times. They'll say enter sightings on Monday, Tuesday, Wednesday, Thursday, Friday. And then we're going to output a list of the days of the week in order. You guys noticing that? Of least to greatest. All right, so now we got to figure out how to make all that happen. All right, let's get over to Visual Studio and create the program to start with. So new project, console app, as per normal. That's the right folder for me. And then I'm going to call it mod 5 lab. And you know what? I'm going to say UFO sightings after it. Why not, right? Makes it a little more specific. And then take all the defaults here and on the last page as well. And now we have a brand new program. I'm going to blow away the existing content. And let's start by setting up an array of strings for the days. So I'm going to do it like this. String, square brackets. That tells me I'm building an array, right? And I'm going to call it days. And you know what? I kind of know what the days of the week are, so I don't need somebody to enter them for me. So I'm just going to hard code them inside curly brackets. I'm just going to do Monday, Tuesday, etc., or be intelligent and copy paste it from the other screen where I already typed it, so I don't have to mistype and have you guys wait forever for me to finish typing. All right, so there's all the days of the week. We also need to build another array. And we're putting in the number of sightings. Sounds like an integer to me, right? The counting number. So we'll do an int array, square brackets again, and we'll call this sightings. All right. Well, I don't know what's going to go in here exactly, right? In terms of the number of entries, or do I? Well, we do. Okay, so I could do it two ways. I could say new int square bracket, and then inside the square brackets, I can just Monday, Tuesday, Wednesday, Thursday, Friday, 1, 2, 3, 4, 5, and just hard code 5 and be done. Right. But then what if I decided to add Saturday and Sunday? Or what if I invented my own new calendar where I have, 45 days in a week or whatever? If you want to make it dynamic, the other approach would be that I could say days dot length. So it would adjust. So if I added Saturday and Sunday, no problem, automatically adjusts. Right. And then, if you want, you can put a little note at the end and say, or you can just hard code a 5. That's fine. Either way it works. All right. Now we're going to prompt the user to enter the number of sightings, correct? And that sounds repetitive to me because we're going to do it 5 times. So I can set up a loop to do that. So yes, Visual Studio, you are correct. And oh my God, yes, correct again. And I know I say this all the time, but it always amazes me how accurate it is predicting the next line of code. And it's really taken me a lot to learn to let go of the reins and go, you know what? I'm okay with a self-driving car as long as it doesn't smash into stuff. And maybe it would have been good during the morning commute today. All right. So yeah, we're going to run a loop. We'll start the counter at 0 because arrays index counters start at 0. We're going to run up until the length of days. Once again, we're making it dynamic. So if we add Saturday and Sunday, I don't have to change my code. And it's going to increment 1 each time. And we're going to prompt our users, and we're going to do this. So we're going to say console write, enter sightings on this particular day. I will start at position 0 with Monday, second time Tuesday, etc. Right? So the prompts will automatically appear. And then every time somebody types in a sighting, we're going to store it in the sightings array, which is going to grab numbers, start at position 0, and so forth until we get to position 4, converting to an integer, right? Because it's coming in as a string. So there's the input all handled. Now, if you remember, we did learn some array methods, right? And I've got to spell array correctly first. And once again, very impressive Visual Studio, close to what I was going to type, but not exactly. So we're going to do array sort. And if you remember, if you put in 2 parameters, it'll sort both the arrays. And then this one is really the one we're sorting, but all the comparable positions in this array will get reshuffled to match the ones that they were originally aligned with. So they'll get restructured automatically together. So sightings days, because remember, we're sorting from the least number of sightings to the most. All right. Now we need to go ahead and output this, right? So we start with for loop. Once again, a repetitive process. That looks good. That looks good too. I'm just taking it, right? It's exactly what I would have typed. Oh, no. Actually, I'm not sure about that. Now it's saying for, okay, so let's talk about this a second, right? My head goes to doing the same thing I've been doing here. I'm going to run it until the length of days. This is running it to the length of sightings. Does it matter? Okay, think about it. They're going to be the same length, right? They're both going to be length 5. But if I dynamically change, well, it doesn't matter, right? Because this is set to be dynamic. So if I add Saturday and Sunday, it'll go to 7, meaning this will go to 7. And you know what? This will go to 7 because this went to 7. So this actually works, right? Normally, my inclination would be to stick with days dot length, but my logic in my brain figured out, oh, this is fine. And the reason this is fine is because we chose the dynamic approach here. If I hard coded a 5 up here, that would not be okay. Right now we just output, right? This is just string output. So this is what I typed. I just did a console write line, string interpolated. I listed the current day that we're iterating through. All right, what's minus 14 about?
It sets like the amount of characters something takes up on the output, even if it doesn't like explicitly hit that limit.
Grayson, spot on. Thank you. Right. So this is just an output technique. So in other words, we want our output. I'm trying to find the lab assignment here to get all matched up. Now, you guys might not be quite so geeky, right? To like go, well, if that's 6 characters, how many characters is that? And well, the answer is 14, total, right? Um, and if you dropped it into like a text editor, you could figure that out. But the point is to make them look consistent. Do I really need 14? Well, it could be 10. The longest day name that we have here is 8 characters long. So we could set it to 10. The only consideration is if I did add Saturday and Sunday, how long is Saturday? Right? Who's counting? Right? Like, okay, we don't care. That's I think that's kind of the end result. But that is exactly what this is. This is a formatting command. So it's going to take up 14 character spaces. Notice the negative sign in there. So I just thought this is a good place to kind of demonstrate that. So how do you get your output to look nice without like doing a bunch of crazy stuff? This is how. If you omitted this and you turned it out and the numbers were off, I really kind of don't care. Right? I'm just showing you the formatting technique. This is all of it. This is the whole program. 16 lines of code, not even. Right? All right. Let's do the run. All right. So let's enter sightings on a Monday. And I think actually they had something like, I don't know, 11, 3, 48. I'm just coming up with whatever numbers. Fridays are busy. So there we go. Then we re-output it. Notice how the numbers are all ordered. Did the numbers and the days move together in the sort? Yeah, they did. So this is sorting parallel arrays. It's also creating a string array, creating an integer array, prompting the user for input, storing it, iterating through it, and doing a sort. Very nice little exercise. Right? That went pretty quick. All right, so that's the Module 5 lab assignment. All right, I'm going to go ahead and close this solution. And I'm going to create a new project. I don't know what I'm going to name it yet, so I'll just go to the screen where I name it and stay right there. And let's go to our instructions now. So I'm going to kind of leaf through the course stuff here just really quick. And here's our assignment. All right, so let's read through this. Create a program that allows the user to fill a vending machine and purchase items from it. The program should use a list of type string. The vending machine always vends the item that was most recently added to it. The user should be able to stock an item in the machine or buy an item from the machine. In other words, we should be able to add stuff and remove it, right? The program should inform the user if the machine is empty when they attempt to purchase, all right? And then this is what it will look like. So a little title, do you want to add item, buy item, or end? So the 3 values we're looking for are A, B, or E, right? In this case, they're adding a Coke, adding a Coke, adding a Sprite, and then they're buying a Sprite, buying a Coke, right? Adding a Dr. Pepper, good choice, I think, right? Especially on ice. Buying a Dr. Pepper, buying a Coke, and then trying to buy something and then it realizes there's nothing left in the machine, and then we click E to end, right? So one of the things we have to do, right? The machine's going to start empty, so we do have to add stuff. All right, so let's try building this. All right. Let's come back to Visual Studio. I'm going to name this mod 5 assignment, and I'll also add to it vending machine. All right, we'll click next, create. And now to think about this now. All right, we do have to create a list of type string. Okay, so I'm going to just pause the recording here for just a moment. All right, let's start by creating a list. So I'm going to, oops, wrong copy paste, folks. All right, so here's my declaration of a list that contains strings, and it's a vending machine. Now remember, the big difference between lists and arrays is arrays are a fixed size. Can't change them, right? Like once I say they're size 5, it's size 5 and it stays that way. But a list is dynamic. It's as big as I make it as my code runs. So this is pretty flexible and a good choice for this. So this is the syntax. I am calling it vending machine. All right. Since the user is going to be typing in a single character to make their add, buy, or end choice, I am going to create a character variable that I'm just going to call option. And I'm not pre-populating it with anything. The user is going to give us that. And if I remember right, they did have a little title at the top, right? Where they did a right line vending machine. And then, you know, if you're counting letters here, it's 7, 8, 12, 13. So I'm going to do a new line and then 13 dashes. Right. Just to make it, you know, my ASCII art once again. All right. Now we're going to do a loop. And I want you to think about this, right? Because the screens that were being showed, and let me get back to that description here. At the very least, and I want you to think about how I'm saying this, right? At the very least, we're going to prompt the user to do this once, right? And normally, if I run a loop, like a while loop is one that we often use to interact with users because we can give them a sentinel value to be able to get out. What's our sentinel value here? Well, it would be the letter E, right? That's like our escape character or whatever. But I also want to at least iterate it once. So normally I might write a while loop and say while, you know, option is not E, prompt the user, right? And in that case, what I would do is I would pre-populate option, right? So it's a letter other than the E, so it runs. Okay, but I don't want to do it that way. If we're going to iterate it at least once, instead of having a while loop, let's have a do while loop where we check the condition at the end. So I'm going to do as my keyword here, and here come my curly brackets, right? At the end, right, we can write the syntax for the end. And we haven't done this much, so this is why this is a good little thing. While, and we're checking the condition at the end of the loop. And what are we checking for? That the option, which is the character they're typing in, does not equal, and in this case, it's going to be the capital letter E. And why am I using single quotes? Because it's a character. And that's kind of a convention in programming, right? That we use single quotes when we do characters. Right. And all our logic's going to go in here. Well, I know for sure that we're going to prompt the user just the way they did on the other screen. So here's the prompt, right? So console write, do you want to add item, buy item, or end? Okay. And then, of course, we need to read that in. We're going to read it into the character variable called option. I want you to notice a couple of functions added to the end of this, right? I did add to upper. So if they type lowercase a or b or e, that's fine. I'm handling it, basically with code. And then there's the trim command. What is, you guys remember what the trim command does? It is a function that basically, and I think I explained this to you guys, right? Like a lot of times when people are interacting with computers when they're typing, we have this habit of we type, hit the space bar, type, hit the space bar, type, hit the space bar. So you might ask somebody for like A, B, or E, and they might type it and hit the space bar, but we don't need the space bar, or we don't need space. So we're trimming it. And so the trim function or method actually gets rid of that extra spacing in there, and real common for doing stuff like this, by the way. All right. So now we got our input, and now we need to check for each one of the options. Now I could write an if statement to do this, but you know what? Let's try some of our other skills. Let's like mix it up a little bit. So let's do a switch case statement instead. I think that would be a nice option because we do have like a finite number of options. We're not checking like if A is greater than X or 5 is greater than 4 or anything weird. Like we're not doing comparisons. We're just taking the option that they chose and we're going to match it up with the code that we're going to need to execute it. So one case would be the capital letter A, right? And we put a colon at the end of it, and then we can do our add. So here's the add statement. I take vending machine. I'm adding an item to it. And what are we adding? Well, whatever they typed in. So for example, Coke, that's what they're going to be typing in. Right. And every time we do a case in a switch case statement, you got to hit a break because otherwise it keeps processing. So if they type A, they added the thing, we're done. Right. Right. The other case is to buy. So capital letter B. Once again, a colon after that. And then, all right, do we just like brute force? Think about this. Do we just brute force this and type in a statement like, oh, you bought a whatever? No, we have to first check to see if the vending machine has any stuff in it, right? If you remember that part. And when we're working with a list, we can't check the length of the list. We check the count of the list. So here's the statement. If perfect Visual Studio, if the vending machine dot count is greater than 0, then we will do what? We're going to do this. You bought a whatever, Coke, right? And I want you to notice here that inside the square brackets, what position are we looking at? It's going to go to, this is the buy, right? They're going to the last position, right? Because the count is 1 too high, so we're subtracting 1 to pull it out, right? To pull out the information. And then, okay, interesting. Well, I retrieved with this statement here, I retrieved the name of what I bought, but I didn't remove it from the vending machine. So I got to do that in a separate step. So I got to say vending machine remove. And what am I removing? The exact same thing that we just looked at. So same position, last one, we're removing it. So first we extracted the information to put it on the screen, then we removed it. It takes 2 steps to do it. This is underlining red. Oh, I got to do a break statement is why, right? Well, I'm still in my if statement. okay, this is if there's stuff in the vending machine. Okay, so what happens if there's not? So we got to accommodate for that. We got to do an else here. So we're going to say else. Just going to give them a message. And I think the message that they used was there are no items in the vending machine. And then we're still in the case of B. And then I'm going to do my break. And that case is done. Next, we're going to do case, capital E, right? I need to check it. And if they type an E, that's going to give them a message that says, thank you, come again, right? Or whatever. And we break and we're out of the thing. Now, this is a switch statement. Do we need a default? Okay. If they type A, B, or E, upper or lowercase, we're fine. What if they type some other character? Okay, we do need a default, right? So we'll put in a default for the switch case. And I would just make it something really, really simple like this, invalid input, and you're out. So that's our switch statement. There's the whole thing. If you're trying to screen capture or whatever, right, that's the whole switch statement. Is there anything left to do? Does this loop and switch case statement handle the whole thing? It does. There's no other code, folks. All right, so I'm gonna zoom out just a little bit on this, as you can see, maybe the whole thing at once. So here's the whole program. We go in one click. So we have our list, character option, title. We go into the dual loop. We prompt them, add, by, or end, right? We read line that in, trim it, uppercase it. Then we check for A, B, or E. We have all our logic put in there. We have a default if they type in the wrong letter. And as long as they're not typing a capital letter E, that loop's going to keep running, right? And so the user controls the entry and exit to the program. Saving, and here comes the run. All right, so let's look at it while we're looking at the code, right, to make it interesting. Right. Do you want to add an item? Okay, so we want to add stuff to begin with. So let's do a add. Now it's waiting for me to type something. You notice it didn't prompt me. It didn't say enter the name of what you're adding, but I'm going to add a Coke, right? Cokes are always good. We'll add again. We'll add another Coke. And then we'll add again, and we'll add a Sprite. And then, you know what? I feel like buying one now. So I'm going to buy. All right. You bought a Sprite. So what am I buying? I'm buying the last thing that was put in the machine, right? That was the instruction, correct? Yes, correct. All right. How about I buy again? All right. I bought a Coke. Well, you know what? I'm going to do what they did, and I'm going to add a Dr. Pepper. All right. Let's buy. You bought a pepper. Let's buy again. You bought a Coke. Let's put in the wrong letter, invalid input, right? Let's buy again. Oh, there's nothing left. It's a good time to end. Let's press the letter E, and we're out. All right. Let me do a quick pause on the recording here. Do it. All right. So we were able to make this work using a list as we were instructed, which is great. But as I've done in the past when I've taught this, and I'm like zooming in on the wrong stuff here. I often would demonstrate doing this with a different data structure, one that we kind of talked about in passing and didn't really see any slides on it or information, but I did give you this analogy of what it is. So the data structure that I'm speaking about is called a stack, which is, my analogy is basically like when you go to one of those buffets and you find those dishes and they're on that spring loaded mechanism that sinks into the counter of a buffet, and you put something in. And that's kind of what we were doing here. I don't know if you guys are picking that up. It's like I could only buy the last thing that was put into the vending machine. Well, that's exactly how a stack works. So like the first item that goes in is the last one I get out. Right. And it works like a stack of dishes. So like if you see my hands here, like this goes in, next item goes on top of it, the next item goes on top of that. And when I go to pull stuff off the stack, I can't go to the bottom item. I have to take the top one off first. And when I work with a stack, we use different terminology. In fact, the terminology that we use is push and pop. Like pushing is adding to the stack, popping is removing from the stack. So let's first define a stack. And I will say that this part of it is optional. You do not need to include this. But if you guys just want to watch, that's fine. If you want to try it, you can do the same thing I'm doing. You comment out the list stuff and then just use the stack stuff instead. So I'm still calling a vending machine using the same name. Notice that the declaration is not that much different. We're just using a different keyword, right? Stack is the keyword instead. Just implies a different data structure, right? All right. So as we pop through the code here, and this stuff is all fine, right? That's not going to change. That's not going to change. Switch statement's still going to be there, but the syntax that we use is going to be a little bit different. So with the list, I would add stuff. But when I'm using a stack, remember I told you the keyword is push, right? So here's what a push looks like. Same approach, right? And we're pushing the dishes onto the spring-loaded mechanism. Think of it like that, right? So we're pushing that read line, the Coke, onto the stack, right? Same thing's going to happen with the subsequent statement here is anywhere where we are removing, right? And I want you to notice this is kind of interesting, because we have a message here that says you bought whatever, right? And that was the approach that we used to work with a list. But when I work with a stack, it's a little bit different. So I'm going to comment out this first line. And what I'm going to put in its place is kind of interesting because the pop statement not only removes it, but also reads the information. This is kind of interesting. So that allows me to remove the remove. So, okay, so why do we have different data structures? All right, so the stack, because there's an order to how the stuff goes in, first in, last out. The pop automatically handles both of the actions, reading the information and removing it from the data structure. So I'm replacing 2 lines of code with 1. I think it's kind of neat, right? But that function relative to a stack does that. So that's the only alteration to the code, you guys. So we just use a different data structure, right? We did a push to add something and a pop to both read and remove. All right, let's run this. I'll show you that it works just the same. And let's see if I can remember the soda algorithm here. So we'll add a Coke, add, I don't know, Sprite. I'm probably going to make it quicker. We'll add, here we go. Let's throw a curveball. RC Cola, something oddball, right? Let's go ahead and buy. Last thing comes out. Let's go ahead and buy. Down to the Sprite. One more time. We're at a Coke. Try to buy again. Nope. We're empty. And E still exits. Right. So demonstration of using a list, a demonstration of using a stack. And the list, we were told, remember, to make it operate like a stack, which led to the example of the stack pretty naturally. Right, same concept. This is not really how a vending machine works, right? Like a vending machine, you go in there and you go, hey, I got 20 choices, and then you pick the choice that you want. That's not the vending machine that we built. We're following the instructions we were given. And folks, this is the solution for the Mod 5 assignment, and therefore this video is done.